In this IGCSE Physics lesson, we are going to master density. First, connect mass and volume. Then use density equals mass divided by volume in real exam questions. Let us begin with the meaning of density. Density is the mass contained in each unit of volume. We calculate it using density equals mass divided by volume. Here, rho represents density, m is mass, and v is volume. Keep the units consistent, grams per cubic centimeter or kilograms per cubic meter. For example, if the mass is 240 grams and the volume is 80 cubic centimeters, the density is 3.0 grams per cubic centimeter. Now compare these two cubes. They have the same volume. The cube on the left contains less mass, so it has a lower density. The cube on the right contains more mass in that same volume, so it has a higher density. Remember, density compares mass with the space it occupies. Key Concept 2. Measuring mass and volume. Every density method needs both measurements before density can be calculated. First, measure mass using a balance. Then choose the correct method for finding volume. For a regular solid, measure its length, width, and height. Calculate volume using length times width times height, then divide the mass by that volume. The balance gives the mass, while a ruler gives the 3 dimensions. Calculate the cuboid's volume before using the density formula. For a liquid, subtract the mass of the empty container from the total mass of the container and liquid. Then divide the liquid mass by its measured volume. So the difference between these two balance readings is the liquid mass. Read the liquid volume directly from the measuring cylinder. Remember the order: mass first, volume second, and density last. Key Concept 3. Use displacement for an irregular solid. A ruler cannot provide the volume of an irregular shape, so we use water displacement. Begin by measuring the object's mass, m, using a balance. Next, rate the initial water volume and record it as V1. Fully submerge the object, making sure it sinks, then read the new volume as V2. The object's volume is V2 minus V1, the rise in water level. Its density is therefore mass divided by V2 minus V1. For an accurate practical result, remove trapped air bubbles and read the bottom of the meniscus at eye level. Key Concept 4. Compare densities to predict floating. The result depends on the object's density compared with the surrounding liquid. An object floats when its density is less than the density of the liquid. Here, the object remains at the surface because it is less dense than the liquid. An object sinks when its density is greater than the density of the liquid. This object moves to the bottom because it is more dense than the surrounding liquid. For liquids that do not mix, the lower density liquid forms the upper layer, while the higher density liquid stays below. Compare the density data before deciding the final order of the layers. Remember, smaller density goes higher and greater density goes lower. Before the exam questions, keep these scoring tips in mind for density. They help you avoid the easy mistakes. 1. Start with density equals mass divided by volume. 2. Choose the correct volume method for the object. 3. Use compatible mass and volume units. 4. Read scales carefully and show you're working. Final check: formula, method, units, readings, and working. If those 5 are clear, your answer is much safer. Keep practicing with real exam questions on EduNinja. You can study by topic, follow step-by-step solutions, build smart papers, and use revision notes when you need a quick recap.